Today we are going to discuss arrays. We'll try to learn how we declare arrays, how to assign values to the arrays, how to access the array elements, how to declare and use two-dimensional arrays, three-dimensional arrays, and how we can pass array as a function argument. And then at the end of the lecture we will discuss the advantages of arrays. Why we need arrays? An array is actually a variable that can store more than one value. It is also referred as a collection of variables of the same type. Let's suppose if we need 5 integer variables in a program, we can declare them as integer a, comma b, c, and whatever name you choose here. But what will happen if we require more than 100 variables, or let's say 10,000 integer variables, or let's say 500 float variable? Then declare those variables in this fashion, it will be very difficult. So we need a simple mechanism for that purpose, and that's why we can use arrays. Array declaration is very simple. If you remember, we can declare the variables also, the type of variable, name of variable, and then semicolon. But in this case, for array, type of array, which type of array you want to declare. For example, we can use integer, float, character, or probably other user defined types. We'll discuss them later. So type of array, name of space, then name of array, name, the rules of the names, they are the same as we discussed for variables, for functions, and then bracket, and inside the brackets we need to mention the size of the array, and then semicolon. So that means that this array is now declared. These are a few examples of the array declaration. For example, this one, int ARR, this is the name of the array, and the size is 5. So this means that we have 5 integer variables. Another example, float xyz8, and then semicolon. You can see this means that we have 8 float variables. Then again, type of array, name of array, and size. So this means we have 10 character variables, integer, type of array, name of array, and size, and semicolon. So this means we have 1000 integer variables. That's very simple and very mechanism to use multiple variables. For this array, the name of the array is ARR, the type is integer, and we have 5 variables, and we know that those 5 integer variables will be stored in contiguous memory location. This is the first variable belong to this array, second integer, third integer, fourth integer, fifth integer. We will discuss then these numbers. Here in this case, these number, they represent the index number. This is the index number, index number, index number, index number, and using these index number, we access different types of elements. So these are the 5 integer variables, and these are the index numbers of those variables. Okay, so it's already explained here in this slide. Now here in this program, you can see we have the same array, 5 integers we have. We can use the first element or the first integer. So the first integer, we are referring of this array as the first element. So the first element of the array, we are assigning value to this first element and the value is 25. 12 is assigned to the second. Remember that index number starts with 0 and it ends with the number of the size of the array minus 1. So size of the array is 5 minus 1 is 4. So this is the last element. So we will start with 0, 1, 2, 3 and we already discussed that they are stored next to each other. Okay, so the third element, the value of the third element is 44 and the fourth element's value is 65. The last one is 200. So this is the value, this is the name of the array, and this is the whole array. The name is this one. This is the name of the array, and this is also the name, but this is the name of this element. We can access this element using this index number, name of array and index number. Name of array, index number, name of array, index number, name of array, index number. So you have to remember that the number inside these brackets, it shows here in the declaration, it shows the size of the array, but other than the declaration, this number shows the index number. So you have to be very clear. When we find this number inside the brackets in the declaration statements, that shows size of the array. Other than those, we will consider these numbers which are inside these brackets, we will consider them as the index numbers. So this is very important to remember. So don't be confused with the index number and size of array. So that's the another way to assign values to array elements. We can write this statement instead of these, because we here in this case we are assigning values to individual elements, assign value to second, third, and so on. But actually this is done by the compiler, and the compiler will assign the first value to the first element, second value to the second element, third to the third, fourth to the fourth, and fifth to the last element. So that the compiler will facilitate us, and it can store the values according to this program. So 1, 2, 3, 4, 5, 6. So this statement is equivalent to these 6 statements. So we can use the simple way. Again, this is the first element, index number, second, third, fourth, and fifth. Now let's use this array and program for our practice. I will ask question about the printf statement, and then you have to think about the correct output. So let's start with this statement. What will be the output of this statement? Okay, so let's calculate. Let this x0, x1, x2, x3. So the output will be 55. What will be the output of this statement? Yes, that will be 0, 8. What will be the output of this one? So x0, x1, x2, x3, x4, x5. So 23. What will be the output of this one? This is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So 50. We can directly guess because the size of the array is 10, and this is 10 minus 1, 9. So that will be the last element. So we can directly check. What will be the output of this statement? This one. But we don't know the value here at this location. So for us that will be a garbage value. So the answer is garbage value, because we are not sure, and that is outside of the boundary of this array. Now let's suppose we want to store the CGPA of 55 students of our class. So we need 55 float variables. We cannot declare 55. We can actually, but it's very difficult to declare 55 float variables. So we will try to use array. So this is type of the array, name of the array, and number of the elements. So we have 55 float variables. Now again, it will be very difficult to store or to assign a value to each float variable, so we will use for loop. You are already familiar with the for loop, the initialization part. So a is equal to 0. If a is less than 55, then execute the body, and then a plus plus a will be incremented. So let's start with the loop. This message will be displayed, and we will store percent. That scanf will get the value from the keyboard. So let's suppose we entered here 2.2. so that 2.2 that will go to where? CSC A0, because the value of a is 0. That 0 will be here. So if we use CSE 20 index 0, so that means that we enter 2.2 at this element. Now for the next iteration, the value of a will be incremented, and the value of a is now 1. And when we store the next value here, then the element will be CSC 20 and index 1. So the next value will go to this element. So that is the second element, and so on. So this is very simple, and simple way to store multiple variables on array using the for loop. You don't need to write the assignment statements for each element. Now this is the breakdown of the previous program. On previous slide, we use an example where we use 55 float variables. In this case, we are using 5 to demonstrate how it works. So it's the same approach we will be using, that is for loop. Again, a is equal to 0, this one. So this index, that will be 0 for the first iteration. So whatever you enter through scanf through this statement, that will go to the first element, because CSC 20 index 0, so that will go to first. So after the incrementation by a plus plus, the value of a is now 1. So the next value for scanf, that will be stored in CSE 20 index 1. So the next value, which is 1.8, that will go to 1. For the next iteration, that will be 2 because of a plus plus. So the next value, CSE 20, that will go to 2, because this is this one and this 2, these are the value of a. For the next iteration, the value of a, that becomes 3. So the next scanf, it will store CSC 3. So the next value, which is 2.5, that will go to index 3. For A5, so this scanf now CSE index 4. Sorry, I need to write 20 here. So the next value will go to the index 4, which is the end of array. When it is 5, this become false. So this, we are done with this loop. Now let's display the values which we already stored using for loop. So here you can see the value of a is now 0 again. So here %d, so 0 plus 1, 1, so that is 1, and the value at 1, that will go to this statement, right? So that is the output. For the next iteration, where a is 1 now, this becomes 1 plus 1 2, so that will be 2, and the next value, which is 1.8, that will go to this one. For the next, which is 2, so 2 plus 1 here, because of this, that will go to this statement, which is 3, and so on. So that's how we use loops for larger arrays. We can use loop for assignment of the array elements, or we can use loop to display the elements or the value of the elements of array if the size is larger. In this case, the size is 5, but we used 5 to demonstrate how it works. So it's a very simple and efficient mechanism for the arrays. A two-dimensional arrays. So as in our previous example, we used arrays to store the CGPA of first semester students in our department. Now we want to store it for EE department, TE department, and CS department. And let's suppose that the number of students in all departments, that is 55, because if that is not 55, then we cannot group them. So just to group them, we will assume that the number of students in our department, they are 55 in the first semester. So to write or to declare multiple arrays like this, we can declare, or we can use two-dimensional array, and we can declare float. UATM float is the type of array, name of the array, and then how many arrays and how many element in each array. So in each array, we have 4 arrays. In each array, we have 55 elements. We have 4 arrays, and in each array, we have 55 elements. So that's two-dimensional array. 1, 2, 3, 4. So we will write 4. And the number of elements is 55 in each array. So we will write 55. So that's two-dimensional array. Here we will see how to assign values to 4 two-dimensional array. We know that we have 4 arrays, and in each array contain 5 elements. So this is array 1, 2, 3, 4, and each array have 5 elements. So we can group them in curly brackets. So that is for our convenience. We can write them. We'll demonstrate that in the next slide. But that is for the programmer's convenience. We can write in the curly bracket, we can group them, so that this group indicate one array, this one second, third, so comma, 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 and then we have the end of this group, and then end of the assignments. So we can assign value in this fashion. So let's resolve this one. So the output of this statement will be 2 and 3. So let's resolve this index first. 2, so that means 0, 1, 2. So this is array number, and this is index number of the element 3. So 0, 1, 2, 3. So 46. So that's the output. Now we will store the result of this expression on this location, which is 46, already encircled. Okay, so resolve this one. 1, so 0, this is 0, this is 1, so that means this is second array, the blue one, and element index number 1, so this is 0, 1, so 34. So this is 34, and this is referring to, so let's resolve. So and array 3, so that means 0, 1, 2, 3, the green one, and element index 4, so 0, 1, 2, 3, 4, so 57. So the output is 91. So that's the output. So that's how access and how we use the array elements. As we discussed on the previous slide, that we can write them in a single line like this. The compiler can adjust them and can store them in the same way, the one we did on the last slide. So it doesn't matter. The way we did on the last slide was just to facilitate the programmer. Otherwise, you can write this. So you can see that these were the numbers, the same numbers we used with the pink color, and then the blue and the purple and the green. So how we resolve here? So 2 3, I guess it's the same example. Yes. So okay, that is the that is the code from the last slide. So you can see 23 24, I guess I missed, this is 23 anyway. 33, this is the second, so we can group here, third one, this one, and this is the fourth one. So how we resolve this one? So it's simple. So we have to group them for ourselves. Let's suppose we don't have this one, so we should group them. So let's suppose you want to resolve 2 3, so 2, so that means 0 1 2, and 3 0 1 2 3, so that is the 46. Now let's resolve this one, 1 1, so this is 0 1 and 0 1, so 34. And for 3 4, this is array 0 1 2 3, array 3, and element number 4, so 0 1 2 3 4, and so that is 57. So the same output. So if we have a straight line, then you can group them like this, so you will not be confused to resolve the index numbers. 57. There is another practice slide, so we will try to find out the output of these statements. Before going to the output, let's group them first so we can easily count them. So this is the first group, 0 1 2 3 4 5, then 1 2 3 4 5 till 6, then 1 2 3 4 5, then 1 2 3 4 5. So we have 4 groups. The index of this group is 0 1 2 3, and the element number we are already familiar with it. Okay, so you need to think about the outputs. What will be the output of this statement? 2 1, so 0 1 2, and this is 1, sorry, 0 1, so the output is 4 3 4. What will be the output of this one? This is 0, and the index element number index is 3, so this is 0 1 2 3, so 5. What will be the output of this one? 3 4 3. This one, 37. This one, 57. This one, 4. This one, 57. This one, 5 3 1. Last one, 2 3. This is 0 1 2, and element 3 is so 0 1 2 3, so 46. So that's the output. For the 3-dimensional array, we will use the same approach. We can group 2-dimensional arrays and we can have one three-dimensional array. For example, the one we use UETM for 4 departments, if you remember. So let's suppose the same another university, UETP for example. Now we want two-dimensional arrays. So instead of having two-dimensional arrays, we can have one three-dimensional arrays. So this is the number of two-dimensional arrays, number of arrays, and number of elements. So in other words, we can say that in this three-dimensional array, we have two-dimensional arrays, and in each dimension we have 55 elements. So that's how we declare three-dimensional arrays. You can see you can assign the values, or you can initialize the arrays using these curly brackets. You can group the two-dimensional arrays in the red, and second two-dimensional array is colored green. So because we have two-dimensional array, so this is one two-dimensional array, second two-dimensional array. The index of this two-dimensional array is 0. The index of this two-dimensional array is 1. So let's suppose 0, 2, 3. So that means this one and 2, 3, 0, 1, 2 and 0, 1, 2, 3. So that is 46. If you remember, it's the same similar example, the one we used for other arrays. Let's resolve these index numbers. So 0, 2, 3, it is the this location, and 1, 1, 1, that means this two-dimensional array, this is 0, this is 1. So this is the two-dimensional array. And then in another one, so 0, 1, so that means this is the array, and then 0, 1, and so this is 34. So the value is 34. Now 0, 3, 4, that means that this is the array 0 and 3, 0, 1, 2, 3 and 4, 57. So 57, so 91 is the output. So that's how we access individual elements in three-dimensional arrays. Now let's use this example to find the values in the three-dimensional arrays, but we need to group them first. So this is the first group, second, third, fourth, fifth and sixth group. Now we need to divide into three because we are having three two-dimensional arrays. So this is the first one, and this is the second one, and this is the third one. So the index of this is 0, 1 and 2. Now what will be the output of this one? So for this two, 0, 1, 2, so that means we need to pick this one, right? And then for this 0, this one is 0 and this one is 1, so we will pick this one, right? And for this one, 0, 0 and this is 1, so 30 is the answer, or 30 is the output. What will be the output of this one? You guess. So for 0, that this one is 0. For 1, this is this subgroup 0, subgroup 1, and for 1, so for 3, that is 1, 2, 3, 4, so the output is 9. For this one, you guess what will be the output? That is 27. For this one, 31. Try to resolve it by yourself. The output will be 29. This one, 7. This one, for 1, so this one, for this 2, 0, 1, we don't have 2, so that means garbage value. So that's the output. So as we grouped one dimension to make it a two-dimensional array, and then we group multiple two-dimensional array to have a three-dimensional. Similarly, we can group three-dimensional array to have four-dimensional array, and similarly 5 and 6. So it's up to the requirement of the programmer. There is no limitation on the dimensions as long as you have proper settings. The main advantages of the arrays in an array, accessing element is very easy by using index numbers, and as compared to using individual element. So if you have noticed that using the 55 float numbers, we use a for loop, and for that for loop we use the for variable as the index number. So that was very easy to access the element, and we can quickly access them for assigning values or for displaying values, whatever the requirement is. It allocates memory in continuous memory location in its element and does not allocate any extra memory for its elements. The main advantage of this continuous memory, we will discuss them in the pointers, that once we access the first element, then it's very easy to access the rest of the elements using the first element's address. The search and sorting process can be applied to an array easily, as we did in the one of the example using for loop. So this sorting algorithm or searching algorithm, you will use that in the data structures subject. Array can be used and initialized efficiently to store multiple values of similar types. Of course, you cannot store a float value in an integer array.